So our next lesson is statistical methods of uncertainty. So we talked about uncertainty in the tool that you use. There's also a statistical method that we can use to determine uncertainty. Okay, so experimental uncertainty, even when using a digital device, is not always plus or minus 1. Okay, most of our measurements have been single measurements, but what if you make several measurements called trials, right? So for the first time you're writing specifically 3 different trials. Okay, so using many trials of measurement data can be used to statistically determine the uncertainty in your measurements. Okay, a good experiment will have at least 3 trials. Okay, the more the trials, the less the error. Okay, so that's up to you. Okay, now your data table should be organized. The best way to do this is using a data table. Okay, a good data table will include a title that includes a number. So up here I have table number 5. Okay, and then in the title I say, what is it? So data table comparing time to distance in this case. Okay, it will have the names, labels of each of the variables. So you don't necessarily have to put independent, but you do have to put the names. So time, and then in parentheses it will have the unit, right? So time in seconds, distance in meters. Okay, you only have to put them in the label, not in the actual measurements. Okay, make sure that your data does not contain any letters. Okay, and there is a link to a data table template if you want to use that. Okay, to determine the uncertainty using this statistical method, first you're going to find the average of all the trials. Okay, then you're going to find the average of the range. Okay, and the range is the difference between the biggest number and the smallest number. Okay, so if I'm looking at my data set here, each one of these is a measurement, right? It's a trial. I'm going to take the average of these numbers to come up with the average, right? So that's going to be your first number. Then to find the plus or minus number, you're going to take the biggest number minus the littlest number and then divide by 2. Okay, so if I look in my data, 1.6 is my biggest number, 1.1 is my smallest number. So if I subtract those, I get 0.5. That's my range. I then divide it by 2 and I get 0.25. Okay, now all uncertainties should be 1 sig fig, right? So instead of writing 0.25, you would write plus or minus 0.3 because the 5 rounds up to the 2 to a 3. Okay, so in this case, this measurement is 1.2 plus or minus 0.3 seconds. Okay. The same process that you can do, in your calculator can be done in sheets. So, with your data table, you have your average and your uncertainties. The final 2 boxes, they use a formula, right? And then, so that formula, once you put it in there, it should populate it automatically. It should figure out your average, of your trials, and it should figure out the uncertainty of your trials. Okay. So to sum it up, experimental uncertainty, even when using a digital device, is not always plus or minus 1. Using many trials of measurement data can be used to statistically determine the uncertainty in your measurements. Your uncertainty is the average of values plus or minus the average of the range. Okay. And then also how to set up a good data table. We kind of glanced over that. Okay.